Hi everyone, welcome to JimsOrbit. In this series, we are going to solve NTSE previous year question of stage 2 examination. I am solving this chapter wise, so on a broader perspective. So basically, this will be problems of number system. This will involve a lot of problems based on divisibility and finding the units digit and so on. Okay, just to let you know, you can see all the problems. I'm just going through them so that you remember what I'm going to solve and you know about it. One more thing, this video is going to be in English. Conversation will be in English language, not in the Hindi or English. The reason is pretty simple, because this exam is given by most of the students of India, and English is a common language, and I hope you all can understand a simple basic language of English, correct? Still the maths will be done as normal way. There are 14 questions to be solved, and I hope you have seen all of them now. So of course you can jump to any question when the video is up. That's your choice. Without wasting much of your time now, let's start with problem number 1 now. Okay, so in this problem you are given that you have to find which is the greatest number amongst 2 to the power 1 by 2, 3 to the power 1 by 3, 8 to the power 1 by 8 and 9 to the power 1 by 9. Now this question, a normal way, the normal usual way of doing it is very simple. You need to make all the terms of this expression, the exponent basically, the same, and then you compare the base numbers. The exponents are equal. If you compare the base numbers, whichever is highest will be the highest. But in this question, solving that way will be a little bit lengthier. Okay. So note down one thing here. It's written that 2 to the power 1 by 2, and one number is written 8 to the power 1 by 8. The other number here is 3 to the power 1 by 3 and 9 to the power 1 by 9. Now you note one thing, I can compare these two very easily and these two very easily because they have a similar base structure. That's 3 square is 9 and 2 cube is 8. So it's pretty easy to simplify this. Okay, now you know that 2 to the power 1 by 2, this is 2 cube. So this is 2 to the power 3 by 8. Absolutely correct. Okay, this is 3 to the power 1 by 3 and this is 3 to the power 2 by 9. Now we can easily make this as 1 by 8. It will be something by 8. I need to make the fraction, the power same. That's what it is. The fractions equal, whatever you call them. So how can you make 1 by 8, 1 by 2 as something as 1 by 8 times of it? So how can you convert 1 by 2 into something like 1 by 8? You need to multiply by 4 and 4. So it will become 4 by 8. Simple. Correct. Now this is nothing but 2 to the power 4 by 8. This is what 2 to the power 3 by 8. You see, this is why I said generally we make the exponents power same and we compare the bases. But I'm going the other way around. I'm saying let the bases be equal. Now you compare the powers. Okay, so you are comparing 2 raised to the power 4 by 8 and 2 raised to the power 3 by 8. So basically 2 to the power 1 by 8 whole to the power 4 is obviously more than 2 to the power 1 by 8 whole raised to the power 3. What you can write this? You can write this as 2 raised to the power 1 by 8 whole raised to the power 4. So x to the power 4, and this is what? X to the power 3. So obviously x to the power 4 is greater than x to the power 3. But only when this is value more than 1. If it is a fractional value, this will change because division will reduce more and more value of it. Correct. But in this situation, it's pretty simple. You are comparing 2 to the power, so basically x to the power 4 and x to the power 3, where x is greater than 1. So this implies that this value is greater than this value. So we are sorted with this part. Correct. Now let us sort this out. We know that 1 by 3 can be made into something like by 9 by just dividing by 3. So 3 by 9 is 1 by 3. Pretty simple. So this will give you what? 3 to the power 3 by 9 is more than 3 to the power 2 by 9. Now you see one thing. You get this is more because again x cube and x square kind of situation. Now you have simple two things to see. This is bigger. So 2 to the power 1 by 2 is bigger here, and here 3 to the power 1 by 3 is bigger. Now we need to compare these two. The problem now lies here. This is base 2, this is base 3. The exponent value is 1 by 2, the exponent value is 1 by 3. Can you make somehow these two such a way that they start to behave equal? We know that the LCM of 2 and 3 is 6. Correct. We know that the LCM of 2 and 3 is 6. This means that if I can convert this into something like the power 6, the fractional power 6 basically, we can easily find these two. To do this, it's a very simple way out. Now you can say that this is 2 to the power, what it will be? If I have to make 6 here, this will be 3 by 6. And this will be what? This will be what? 3 to the power 2 by 6. I have just told you one very important point. What was that? This is x to the power 4 when I said it. So I brought fractional this time inside. In this case, I'm doing a little bit different. Why am I doing different? Because the bases are different. In the last case, the bases were equal. So it was easier to say that x to the power 4 and bringing 1 by 8 inside. Then 1 by 8 was both in the inside power and it became x to the power 4 kind of situation, and this became x to the power 3 situation. Correct? But in this case, we cannot do the same way, because bringing 1 by 6 will give me 2 to the power 1 by 6 and this will give me 3 to the power 1 by 6, which is not a good thing. So bring the power 3 rather. Okay, so bring 2 cube and keep 1 by 6 outside. You're learning a lot of things now. Bring square inside and keep 1 by 6 outside. Now you see it is 8 to the power 1 by 6. This is 9 to the power 1 by 6. Obviously 9 to the power 1 by 6 is more than 8 to the power 1 by 6, and henceforth the answer is 9 to the power 1 by 6 is the greatest value, but it came from 3 to the power 1 by 3. It came from, just a minute, it came from 3 to the power 1 by 3, and hence 3 to the power 1 by 3 is the largest value. So our answer is 3 to the power 1 by 3. I hope you have understood this. I have taught a lot of concepts in this question. Hopefully you'll understand and use it in some other questions. I'm teaching you through concepts, okay? Let's do the next one. Okay. In this problem, it's written units digit in the number 12357 whole bracket 655. Okay. In this question, remember you are only looking at the units digit and not other digits. And you are only looking at the power, and this you are not caring of. No care. Nothing. So we are looking for 7 to the power 655. Whatever comes in the units digit of this will be. But we cannot find 7 to the power 655. Of course, isn't it? So we have called a cyclic property for all power questions, all unit digit questions. Now what is cyclic property? If you do 7 to the power 7, you get 7 to the power 1, you get 7. If you do 7 to the power 2, you get 9 in the end. So 7 to the power 3, you get 343, which is 3 in the end. And 7 to the power 4 will give you 1 in the end. I do not care what it gives me here. And 7 to the power 5 will return 7 in the end. Of course, because one more 7 multiplied by a units digit number 1 will give me 7 in the end. You can do it if you want to. But now, note here what happens. The units digit are going to repeat after a period of 4. Okay, so just give me a moment. Let me keep it here. Yeah. So units digit is going to repeat after a period of 4. See, you will again get 7, 9, 3, 1. So it's a cyclic pattern. That's why it's called a cyclic property. This implies a pretty simple thing. It says to us that if it is 655, just look out how many 4 times you can remove from it. So you know 655, if you divide by 4, you get, oh sorry, I wrote the final answer. Stupid me. So this will give me 25, 4, 6 are 24, 15, 4, 3 are 12. So 3. So basically 3 is something which will be left. So basically this is cyclic property will give me whatever comes in the units digit of 7 to the power 3. What comes in the units digit of 7 to the power 3? It comes out to be 3. It comes out to be 3. So just a minute. Yeah. So we can say that, what we can say? We can say that this answer is going to be option number, I don't know why my colors are not changing somehow. So, okay, it will go fine. So the units digit that comes out to be is 3. Okay, got it? Fine. So let's do the next one. Okay. In this problem, it's given how many pairs of natural numbers are there so that the difference of their squares is 60. Okay. You are telling me, the question is telling me that the difference of the squares of two numbers is 60. I'm considering that x is greater than y. I'm considering that x is greater than y, therefore the square of x is more than the square of y. Okay. Now, how many pairs of natural numbers are there? Natural number, this is a very important point to note, otherwise there will be infinite of it. How we cannot find, correct? So, natural numbers, so there will be finite natural numbers. The difference of their squares is 60. Now, you need to apply some simple identity which you have read before. X plus y and x minus y. Okay, so now you have got two values to solve. Okay, let me make a box for you and let me just bring a very simple way of doing it. Okay, okay, not better than this, I can't do, sorry. So we have to find, so it is written that x plus y and x minus y product is giving me 60. Now you know what numbers can give me 60. The first is, if I write it as 1, the other is 60. Now you cannot write this as 1. Why you cannot write this as 1? Yes, because if the sum is 1, of sum of two natural number will be greater than the difference of the two natural number. It will be always true. Correct. So the sum will always be higher. So how can x plus y be 1? So only x minus y can be 1. This can be 60. This can be true. Now this can be 2. This can be 30. This can be 3. This can be 20. This can be 4. This can be 15. And so on. You have to go on. Just a quick writing of the 60 is not a big number to be worried about. 6 is gone. 8, 9, 10. 10 is there. So this cannot be 10. Okay. You are stopping now. Why? Again the same rule. This has to be more than this. You cannot go for any other number. Now you just see one thing. It's if I add these two equations, notice one thing now. If I add these two equations, I'll get 2x equal to 61. So it means x will be 61 by 2, which is not a natural number. You get my point what I'm saying? I'm saying if I add these two equations, so what will be 2x? 61. I'm just adding it beta. Okay. So x plus y, x minus y, 2x, 61, 32, 23, 19, 17 and 16. Now you note one thing. Okay. Now you note one thing, that 2x should be an even number. This whole should be even because x is a natural number. If x belongs to a natural number, 2x should be a natural number, but even, always even, because it is 2 times of it. So you just find which numbers are even. Okay. So you get 32 and 16. There are only 2 numbers which are even, which will give you x as even value. X as a natural number. Okay. So only 2 of them. So similarly y will be obviously. So how many pairs exist? Only 2 pairs. Only 2 pairs. You get my point? Good question, isn't it? Okay. Let's solve the next one. Question number 4. The sum of any 3 distinct natural numbers, okay, arranged in ascending order. Okay. So the first is smaller than second, is smaller than third. Okay. The sum of any 3 is ascending order is 200. So if I add these 3 numbers, I get 200. Okay. Such that the second number is a perfect cube. Okay. This is a perfect cube. Okay. How many possible values are there for this number? Okay. To solve this question, if you have to find, this is a perfect cube. Now the problem is this perfect cube cannot be 125. See, why 125 I took? Because 125, the next higher at least natural number, the lowest natural number which is just higher than 125 is 126. The smallest natural number which is just higher than 125 is 126. But the sum of these two is more than 200. And hence you cannot take 5 cube, which is 125. Beyond 6 you cannot check, because 6 cube is 216. How can the sum of 3 positive numbers be equal to 200 if one number itself is 216? You get my point? So it is not happening. So what happening was maybe 5 could have happened, maybe, correct? But this point you find that 5 cube is 125. This is not happening again, because 5 cube is 125 plus 1 is 126. The problem we are running is more than 200. So this is not true. Can 4 cube happen? Yes. If 4 cube happens, you get 64. What if 3 cube happens? 27. What if 2 cube happens? 8. What if 1 cube happens? 1. The problem is now we are running into is we cannot write 1. But why? Because the smaller number just below this is 0. And 0 is not a natural number. Again, you get the point. Such a good question, isn't it? Such a good question. They want you to take 4. The moment you find this, they want you to take 4. But wait. Correct? But wait. You find that 1 is also not happening. Because if 1 happens to be the middle number, the just smaller number is 0. and 0 is not a natural number. And hence you are stuck with only 3 of the correct cubes, 64, 27, 8. They can be any number. It's not required that they should be 63 and 65. No, it's not like this. They can be any number. The sum should be 200. It is possible now. I can take any two numbers and adjust. Correct. So which is we are not doing, of course. So we have found 3 numbers which are satisfying the following given conditions. Okay. I hope you understood this question too. Let's move to the next question. Now this is a very, very good question. I'll make it the best question out of so far. Very good question. Actually, all the questions are good, but this is superb. Okay. If AABB is a 4-digit number, okay, AABB is a 4-digit number, got it, and it is also a perfect square, okay, also perfect square, okay, then the value of A plus B is, so what will be the value of A plus B? Okay, now you have to understand one thing. Any number of 4-digit can be written in the form of, this is the 1000th place, so 1000 A, this is the 100th place, so 100 A, this is the 10th place, so 10 B, this is the units place, so B. Every number you need to write like this. You know how to write a number now. You know 23 is what? 2 times 10 plus 3, so it is 10 times the 10th digit plus 1 times the units digit. That's what when you get a 2-digit number. Simple rule, class 3. Okay. Now this whole term, if I make this happen, this will be giving me 1100A and this will be 11B. Now if you make take 11 common, you get 100A plus B. Now you need to remember, understand a lot here. So please listen very, very carefully now. Okay. At this point, you find that 11 times something is happening, but still it is giving me a perfect square. Now it cannot happen unless there is one more 11 to this. So what I mean to tell you is 100A plus B should be a factor of 11 times K. So I'm not sure what it will be, but 100A plus B will be 11 times a number. Will be 11 times a number. Okay, so 100A plus B is 11 times a number. Now this number itself should be a perfect square too. How beautiful this question is. Correct, isn't it? So 100A plus B should be a factor of 11. Why? Because I need 2 11s to make it a perfect square, and 11 is a prime number. It is not going to be paired with any other thing. So it's the smallest number. So you need to find the same number for it to make it a pair. Correct? So you need 11 times of 11. At least 1 11. I'm saying at least 1 11. There may be that, like there are 3 11s now. I'm not sure, but at least 1 11. And the other number, whichever is left, should be a perfect square too, because the whole number is a perfect square. So if I get 2 11, I need to get 2 2s or 2 4s or 2 3, 2 6, whatever I get, I should get at least 2 of the same thing. Correct? Now, this means that I know that this K I have to start putting out. Now, if I put K as 1, you get 11. How can 2, so A and B are natural number. Obviously, they are digit. No, they are whole numbers. I'm sorry. So they are between 0 to 9. They are digits. So 0 to 9. So A and B can only be 0 to 9. They can move from 0 to 9. Okay. Now you know you cannot put A as 0 because then it will not be a 4-digit number. So A cannot be 0, but B can be 0. This is allowed. Okay. Now listen, if I put A, the least value for A is 1. If I put A as 1, this number is going to be more than 100. So I am pretty sure that this whatever number is more than 100. Okay, this whole number is going to be greater than 100 because A least value is 1. Correct? A least value is 1. So 100 plus something is more than 100. Now, at this point, I need to multiply it. Now think of 2 square is 4. So I know 4 is a perfect square. But 11 into 4 is just 44. Leave it. 9, 99. Leave it. 16, 176. Okay, let's check for 176. Can 100A plus B be equal to 176 for any A and B? I think no, because if you put A as 1, you get 100 plus something, which is going to be 176. So this should be like 76. How can a digit be 76? B is just a digit. It's just a digit. Correct? So this cannot be 76. Now done. If you put A as 2, the next for A is 2. You can put A as 1, 2, 3 and so on till 9. Similarly, you can put B as 0, 1, 2 and 9. The problem you are running with 2 is 200, which is not 176, more than 200. This is coming. Okay. So 16 is gone. 25. So 25 into 11 is what? 275. I'm just making it here now to make it a little bit faster. So 275. Okay, 25 into 11 is 275. Again, if you put 2 here, you get 200 plus 75 you need. Not possible. If you put 3, how much you get? No, not 3, sorry. 6 square, 36. So 396. So the next is 396. Again, if you are stuck, because if you put A as 4, you get 400. If you put A as 3, you get 300 plus 96. Not possible. Okay, how much have I done? 6. Okay, 7 is square. 49. Okay, 49 into 11 is how much? 49 into 11 is 9, 9, 4, 13, 1, 539. Oh, again, not happening, I think so. 49 into 11 is correct, I'm doing now. 9, 10, 12, 13. Is correct. So 539 not happening, because if I put A as 5, I have to get B as 39. Not possible. Okay, what about 8? So 8 square is 64. What will be 64 into 11? So 64 into 11. So 4, 6, 7. Okay, so 7 not 4. 7 not 4. If I put A as 7 and B as 4, I will get 7 not 4. Done. Got it. So now you are finding that A was 7 and B was 4. The number was 7744. It's a perfect square. It's a perfect square of, because I put 64, so it was 8 times 11 ka whole square. So it was 88 whole square. Okay, 88. Okay, so this means that I need to just add the digits A and B. So you can say 7 plus 4, which is 11. Got it? Okay. Why I'm moving so fast? If you feel like, I don't think I'm moving very fast, but yeah, if it is, you people are doing stage 2, isn't it? So you people have that kind of knack for holding out or catching the main concept. So why to waste your time and my time? Let's start. Which of the following numbers is the 4th power of a natural number? Okay, it's a pretty simple thing. You just look out for the last digits. All of them are 52. Now just look out for this. You know that units digit 4 times will give me the last digits. Okay, so 1 to the power 4 will give me end of 1. Oh, it's a chance. I can get 0, 1 also. It's a chance. I don't know what it is here. It may give me a 0, 1 in the end. Correct? Okay, let's go for 2 to the power 4. 16. Oh, 0, 6. Not happening. 3 to the power 4. So 81. Oh, not happening. So any number's 4th power will give me a digit and the end as 81. And 81 is none of this. So it's not happening. 16 is not going to happen because it's written 0, 6. 0, 1 only has got the chance so far. Okay. 4 to the power 4. 16, 256. 56, not happening. 5 to the power 4. 25, 625. 25, 5, 25. I think it will be something like 5 in the end, but there is no 5 in the end. So leave it. Okay, why to waste my time finding it? 6 to the power 4, again there will be 6 is a 36, 36, 36, 6 is a 42, 2, 4, 6 18, 4, 22, 2, 6 is 18. Oh, something 02 is happening. Not happening, 02 is not happening. No, I'm sorry. 6 is a 36. Sorry. It may happen. 6 is a 36, 6, 3, 6 is a 18, or 4, 22. 3, 6 is a 18, 8, 1, 3, 9, 1, 10, 6, 0. Okay, I have to check the 4 digit now because it's 52 also. So 6, 0, 1, 3. Oh, it left out. 1306 will be in the end. Not possible. It's 52. So it's not happening. 7 to the power 4. You check similarly. You get 343 times 7. 7, 21, 1, 2, 7, 4, 28, 2, 30, 0, 3, 7, 21, 3, 24, 2401. Oh, it's gone. It's 5201. I have to check the 4 digit. I was just worrying about this, but once I get this, I do check for the last 2 digits also. More 2 digits. Okay. Okay. 8 to the power 4 will give me what? If I do 8 to the power 4, 8 is just 64 into 64. So 4, 4 is 16. What I'm writing, man? 1, 4, 6, 24, 1, 2, 56, 6, 4, 24, 2, 3, 84. Okay. 6, 9. 96 is not happening in anyone. Leave out. Don't add more. 9 to the power 4 is 81 times 81. This can have a chance to give me 5201 in the end. I'm not sure. 1, 1, 8, 8, 64, 1, 6. Oh, it's gone off. Not giving me the chance of 0, 1. So nothing, no one is giving me 9, 9, 10, 10, 100. I'm not doing 1000, last double zero is not there. So just only one of them may have a chance. Only one of them, okay? So only one of them may have a chance. So 0, 6 happened, but 13 came out, so it couldn't happen. Okay. 0, 7 never happened, correct? So no chance. 0, 9 never happened. Okay. 0, 6 did happen. Okay. But it didn't catch up with the last more 2 digits of it. So the only option that can be true is part 1. Whichever it is number is, I don't care now. Because not required, no. So it's answer number 1. Okay, let's do the next one. In question number 7, it's saying that the square of an odd integer must be of the form this. In this question, if you notice one thing, most of the options are written in the form of n. So in grade 10, you are already taught one thing. What was that? That if a number, I cannot take n. So let's say the number can be in the form of 2q or 2q plus 1. This was told to you as even, and this was told to you as odd. Correct. Okay. Now notice one thing. We need an odd integer square. So consider the form of 2q plus 1. So what will be x square? The square of this number will be 4q square plus 4q plus 1. Correct. Now in this, if you take 4 common, you get, this is taught in Euclid's, correct? Q square plus q plus 1. Now this will give me 4m, not n, n plus 1. I am considering it as n. Okay. Now x square is equal to 4n plus 1 can be the answer. But it is saying that, but may not be 8n plus 1. It's saying may not be 8n plus 1. But why? Why is it so? Why it cannot be 8n plus 1? Okay. Let us check another kind of odd integer. Why? Because we need to find the counter example for it. If it is not, then only we can say. Let's see. If I take x as 4q plus 1, again I will get odd integers. Correct. Okay. So if I square it, now I will get 16q square plus 8q plus 1. Now if I take 4 common, no, sorry, 8, I'll get 2q square plus q plus 1. Now this will give me 8n plus 1. Okay. This can give me 8n plus 1. So why did they say that but may not be 8n plus 1? So this cannot be true. Why? If I put n as 1, I get 9. And the square root of 9 is 3. So it is giving me an odd integer for n equal to 1. So this is not a correct statement. Now I can never get 6n plus 1 or 6n plus 3, even if I take any other odd integer format. This is an odd integer series. You know this, no? This is a general term for any odd number. You put q as 1, 2, 3, 4 and so on, you can find it. As even as -1 you put, you will find something. Negative obviously, but yeah. But yes, you can get 8n plus 1 too. At some point of time, you can get 8n plus 1. So saying that but may not be 8n plus 1 is not a correct statement. So the thing is, we are getting this cannot be possible, this cannot be possible. Only this can work out, 8n plus 1. So yes, 8n plus 1 will give me. Now put n as 1, you get x square as 9, which is the square root. If you take the square root, you get 3, which is an odd integer. So it's working fine. So 8n plus 1 works. So it should be of the form 8n plus 1. Yes. If I take n as 1, I get 9, which is correct. So this should be the correct answer. Okay. For this, you cannot put n as 1. You get 5. That's the trouble. That's another way of checking it. Your choice. Okay. Next question. Okay. If the sum of 3 consecutive odd numbers, consecutive, one by one, is a perfect square between 200 and 400. Okay. Let the 3 consecutive odd numbers be x minus 1. No, odd, no. So x minus 2, x and x plus 2. Okay. Is a perfect square between 200 and 400. That's one of the good thing it told us. You know that's why. A perfect square between 200 and 400. There are not many perfect square between 200 and 400. So let's start. What's the one perfect square? You have got 225, 15 square. Then 16 square, 256. Then 17 square, 289. Then 18 square, 324 and so on. So there will be like 19 square 361, I think so that was the last one, and 400 between, so you cannot take this one, so leave it. So only these are the perfect squares between 200 and 400. Okay, now it is saying that the sum of three consecutive odd numbers. So let's consider x is an odd number. Okay, x is an odd number, let's say 7. So what is the smallest odd number than this? 7 minus 2, which is 5. What's the other one? 7 plus 2, which is 9. Works out. So this is why I have selected this. It was taught to you in AP, selection of terms, but you never used it in this way. You used in A minus D, A and A plus D. This time you are applying a little bit of particular case to it. You are putting D as 2 to get odd numbers only, isn't it? So if I add these three, the sum is a perfect square. Sum is a perfect square. So x minus 2 plus x plus 2. Why I did it? Because 2 and 2 will get cancelled. The sum will come out to be 3x. So 3x is a perfect square. It's such an easy thing to find. If 3x is a perfect square, that number should be divisible by 3. Why? Because x is just an integer. Sum of three consecutive odd numbers, or integers. It should be integers. I think if they're not mentioned it should be integers, at least numbers or natural numbers. Because for any other number, there will be infinite answer beta. Okay. So consider it as integers, because then only it is possible. Okay. Now 3 times, so it should be a multiple of 3, or x should divide this number by 3 completely, whatever this number is. Now if I put 225, don't put, check your divisibility rule beta. Okay. What is the divisibility rule for this? Sum of the digits should be divisible by 3, correct? Here it is 9. Okay. Okay, here it is 9. Here it is 6, 2, 8, 5, 13. I know this is the answer. I know this is the answer. I'm just counter giving you the why it is not. This is 19. This is 6, 4, 2, 6, 3, 9. 324 is there. Okay. And this is 10. Okay. So I've got 2 9s. So the answer can be 15 or answer can be 18. But 18 is not an odd number. Correct. Is a perfect square with 3 consecutive odd numbers. Now you see what happens if you take 324 and if you divide it by 3, you get 108, which is not an odd number. So x is even, where it was said it is sum of odd numbers, 3 consecutive odd numbers. So you know why I cannot take 18, because it's 324 and divide by 3 will give me an even number. So 225 if I divide by 3, 225 if I divide by 3, we get 3, 7, 21, 3, 5, which is an odd number. And hence it works out. So 73, 75 and 77. These are the 3 numbers. Okay, if you add them, you get 225. Okay, so our answer is 50. I hope you understand why I did all of this, to find and tell you why it was needed. Okay, let's do the next one. Okay, in this question it is being said that on dividing 2272 as well as 875 by a 3-digit number, we get the same remainder in each case. Okay, very good question again. I told you already these are all good questions. So listen carefully. You are dividing 2272. So you have been told dividend is equal to divisor into quotient plus remainder. I'm not what is the quotient, and I'm not told what is the remainder. Okay. The second case, 875, divisor into quotient. I am not told the remainder. Okay. But it is being said we get the same remainder. So why I am taking R1 and R2? I don't need. Okay, this is how I should teach you. First a general way, then use the particular situations, isn't it? Okay, now I have been told that this is the only thing you have been given. You have to find the sum of the digits of this n. Okay, it's a very good question. Okay, just for one step. First you subtract these two equations, get rid of this r at least. So what you get? 7, 9, 3 and 2. No, 1. I just checked once. 11 minus 12 minus 5, 7. 11 minus 7, 16 minus 7, 9. 11 minus 8, 3 and 1. Okay. And this will give me n common because it was multiplying. So q1 minus q2. So far fine. I hope you understood so far. Okay. So now it's given that on dividing this at this by a 3-digit number. Okay, it's a 3-digit number also. Great. It's a 3-digit number. Okay. This is another information I just missed it. Just a minute. Okay. We get the same remainder. The sum of the digits of n can be 10, 11, 12 or 13. Okay, let me think now. Just give me a moment. I have to think now. If I can say what I can say, the difference of the quotients, and this is n. So if it is on dividing 2272 as well as 875 by a 3-digit number n, we get the same remainder. Okay, I could remove the remainder. Now I found the situation. The sum of the digits of n in is, okay, consider a number. Okay, so this is whatever, this is a 3-digit number. So 400 into 3, 1200. And this is going to be our number which is going to divide completely. Okay, what it will be divided by? 314. This is not going to be divided by any like random number. It should be only divided by a particular number. So Q1 minus Q2 will be unique. This is the only thing that can happen. Okay, so it should be a unique digit. So we know that this is 400 times 3. So 1200. 400. I'm just guessing it. If it is 3, this will be 400, like this, 1200. So it will be more than this. So 503, it is not happening. Let's check whether this is divisible by 3 or not. 4, 11, 20. No. Is it divisible by 5? No. Is it divisible by 6? Because this will be a difference. No. So this will be a very smaller number. It will be divisible by 2, 3, 4, 6, something like that, because the rest numbers are just multiple of those numbers. Okay. So it must be divisible by something which is just prime. Okay. Just something which is just prime. So 7, the 7 divides this. 7 1 is 7, 69, 7 9 is 63. Oh no, 7 doesn't divide. 11 1 is 11, 29. 11 2 is 22, 11 7 is 77. Oh, it did divide it. You get the point? What I just did? I knew that this number is going to be a unique number. This, whatever has come, has to be unique. And it should be a prime. Because then only it will give me some number which is 3-digit. It cannot give me, I cannot take a very big number also. So those are restrictions already were there, input. Okay. So if I take n into 11, I get this as 1397 and n will become 127. So n is 127. This is a 3-digit number. It works out to be perfectly fine. So the sum of the digits is 10. So the answer is option number 1. I was just missed it. I was just about to miss it. But yeah. And then I realized that this is not possible unless this is unique. Okay. Next, question number 10. So what it says, the sum of all the possible remainders which can be obtained when the cube of a natural number is divided by 9. Okay. Cube. Okay. It's saying cube. And division is happening by 9. Just apply just a simple normal way. Any natural number, 2 cube. Sorry for the red color. 2 cube. Which is 8, divide by 9, the remainder will be 8, of course. 9 zeros are 0. 3 cube, 27, divide by 9, obviously remainder is 0. 4 cube, 64, 9 7 is 63, 1 is the remainder. I'm writing the remainders here, okay. Okay, 5 cube, 125, okay, 9 1 is 9. You will see there will be a cycle, okay. This will be the cycle, it will happen for every number. That 9 1 is 9, 35. So 9 3 27, 8, the cycle has come back. You check, you want to check it, just check once. 6 cube, 216, 9 1 is 9, 36, 9 4 is 36, 0. So 801 is the cycle. This means these are the only 3 remainders which will happen. Every time you divide any number, it doesn't matter. It doesn't matter because this is cyclic. So what is the sum of the digits? 8 plus 1, 9. The sum of all the possible remainders, sum of the remainders, 8 plus 1, 9. All possible, not all. Okay, so the answer is 9. Sorted. Okay, let's solve the next one. Okay, what it is saying, when a natural number x is divided by 5, okay, if I divide x by 5, the remainder I get is 2. When a natural number y is divided by 5, the remainder is 4. The remainder is z when x plus y is divided by 5. Oh my god. If you want to solve it faster, without any kind of detailed concept, just put a number x which will give you a remainder of 2 when you divide by 5. 7, x is 7. 5 ones are 5, remainder is 2. Sort it. Take something which will give you 4. 9. Y is 9. 5 ones are 5, 9. 9 minus 5, 4. You get it? X is 7, Y is 9. It works out? Yes, it satisfies. It's enough. It's enough. So just add these two numbers. You get 16. Divide it by 5 again. What is the remainder now? 1. What is the remainder now? 1. This is what Z is. Z is the remainder. So Z is 1. Put Z here. 2 ones are 2 minus 5. Minus 3 by 3 is what? Minus 1. So the answer is option number 1. Solve. Again, apply your brain. The remainders were 2 and 4. If you add these numbers, it means they had 2 and 4 more. So the total number more is now 6. So now 6 is the extra number which needs to be divided by 5. So 5 ones are 5. The remainder should be 1. This will always be true for any x and y. You get the point. Okay. So this is how you find that. Find that the remainder is 1. But why to waste your time thinking like this? Just take some random numbers, the smallest one possible for you, and just solve whatever they are saying to you. Okay. You have to find a value of this. Z you found out. You just put the value of Z. Okay. Let's solve the next one. What it is saying now? The x and y are two non-negative numbers. Non-negative. These are very important point. If you do not know these things, non-negative means 0 is included. Non-negative means 0 is included. If it is said only positive numbers, then you do not include 0. Positive numbers means from 1 to infinity. Obviously 1, 2, 3, 4 and so on. And non-negative means 0 to infinity. Oh, I need to use a box bracket. Stupid me. Okay. If you are taught the set theory, this will be the wrong way otherwise. Okay. 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 Let's start again. X and y are two non-negative numbers. Fine. Such that 2x plus y is 10. 2x plus y is 10. Okay. There cannot be much numbers then. Very small number. Let's just make a table out of it. X and y. Put x as 0. You can, because non-negative. This is why it is important. X as 0, y is 10. X as 1, y is 8. X is 2, y is 10 minus 4, 6. X is 3, 3 2 just 6, y is 4. X is 4, y is 2. X is 5, y is 0. Done. You cannot put any other number because you will get negative numbers now. Solved. Okay. The sum of the maximum and minimum values. Great. You have to find the maximum and the minimum value of what? X plus y, and then you have to find their sum. The value of this and the value of this. You have to add. Okay. First you find x plus y. How we will know which is maximum and which is minimum otherwise? Correct. Okay, let's start. 10, 9. I'll use different color. Okay. 10, 9, 8, 7, 6 and 5. Okay, so the smallest is 5 and the greatest is 10. So you have to find the sum of these two. So 10 plus 5 is 15. So the answer is 15. It was an easy question, very easy question. Compared to the last one and the previous one before, this was very simple. Okay, only 2 questions are left and we'll be done with this whole previous year questions of number system stage 2 paper. Okay, let's do the next one. Which of the following digits is ruled out in the units place of this for every positive integer n? Are you kidding me? Such an easy question. You have to find which is ruled out. Obviously, what is the 2 to the power digit gives me? Just add 1 to that digit. Simple. So what is 2 to the power 1? It gives me 2. So if I add 1, I'll get 3. What is 2 to the power 2? It gives me 4. If I add 1, I'll get 5. If I get 2 to the power 3, it gives me 8. What is 8 plus 1? 9. Because you have to add 1 to the units digit. Okay, 2 to the power 4. What's the units digit? 16. 6 is the units digit. What is 6 plus 1? 7. Then it will repeat. I have told you this is a cyclic property. So it is a periodic property. It will repeat after 4. So it will repeat after 4. So it will give me again 2. So not required to check. 3, 5, 9, 7 are only allowed. 3, 5, 7. What is 1 doing here? Just remove it. That's the answer for us. These are allowed. These can come for any value of n. I'm not sure if n is 1, 2, 3 or 4. But yeah, I will not go for 12 to the power. That's a stupid thing to do. Okay. You should go for the units digit power only and check the units digit only. Okay. 14th. Okay. The odd natural numbers have been divided in groups. Oh my God, this is a very beautiful question. Very good question. Okay. Very, very good question. Okay. Okay. The odd natural numbers have been divided in groups as this. Then the sum of numbers in the 10th group. Okay. Now you just check how the groups are decided. 1, 3 is the first one. 5, 7, 9, 11. I'll give you a trick method, not a normal method. Normal method, normal classes. Trick method, JimsOrbit classes. 13, 15, 17, 19, 21, 23, and so on. Okay. You see how I'm going to solve this question. Okay. You see, this is always going to be the sum of odd numbers. Sum of odd numbers. Okay. You are told that sum of first n odd numbers is n square. I hope you are told if you add 1 plus 3 plus 5, what you get? 9, which is nothing but 3 terms ka square. Got it? You get the point what I mean to say. First n odd numbers, but you have to start with 1 always. Always 1. Okay. So then the sum of the numbers, if I have to add the numbers in the 10th group, there will be many numbers. How many? Okay. In the first group, there are 2 numbers. In the second group, there are 4 numbers. In the third group, there are 6 numbers. So in the 10th group, there will be 20 numbers. It's just doubling out. So in the 10th group, there will be 20 numbers to add. But what the numbers will be? If you go by the conventional approach, it will take a longer time. Now understand the tricky approach, the short trick approach. Okay. If you notice, it is the sum is 1 plus 3, which is 4, which is nothing but 2 square. So in the first case, the sum is 2 square. To add these 4 numbers, we can add 1, 3, 5, 7, 9, 11. That is 6 terms. And we subtract the beginning 2, which is nothing but 2 square. I already told you that the sum of first n odd numbers is given by n square. But this is the next 4, not the first 4. So you cannot write this is only 4 square, which is wrong. So you say this is first 6, I subtract the first 2, I'll get the rest 4. Correct, which is true. You get the point. Okay. So now how many of numbers will be there? Now you know this is 2, this is 4, 6. So 6 is already here, 6 numbers already here, 6 are more, so 12. Minus the 6 previous. Did you get the pattern? Did you get the pattern? What I am doing? I'm saying the sum of these 2 is 2 square, the sum of these 4 is this, the sum of these 6 is this. I'm adding the first 12, I'm removing the first 6, I'm getting the next 6. So I already told you that in the last 10th group, there will be 20 numbers. So basically the first, how many? There will be 20 numbers. Okay. So starting from whichever number, I'm not sure, but this will be 20 numbers. Correct. Okay. So if you go like this, notice one thing. This number, I'll come back to that just a minute. Just notice that this is the last, whichever number. Okay. But I have to find this, what is this number? I cannot say 20 square. Why? It is wrong. Did I say 6 square here? No. This was 12. Why? Because I started counting from 1, 3, 5, 7, 9, 11. And then I got the total as 12. So I cannot say this 20 because this is 20 inside the bracket. Before this, how many? I don't know. But if I find it, I can easily find the subtraction. Isn't it? So think now. Think. This is what you know. 1 into 2. This is, you know what? 6 is what? 2 into 3. And this is the square of it. What is 12? 3 into 4. This works out. So first group has 1 into 2 square. Second group is 2 into 3 square. Third group is 3 into 4 square. So 10th group will be 10th into 11 square. So this will be what? 110 square. So in the 10th group, there will be total, if I count the previous behind and everything, 110 square. Okay. What is this number? It is just the previous number. It's just the previous number. So what will be the previous for this? 9 into 10. So it will be just 9 into 10, which is 90 square. So 110 square minus 90 square. Are you kidding me? A square minus B square. 110 plus 90, 110 minus 90. So 200 times 20, which is 4000. Your option number 1 is there. I hope you enjoyed this. There is a natural way of doing it. There is a normal way of doing it. That's called AP, arithmetic progression. And then there is a way called JimsOrbit way. Okay. I hope you have understood this question. And if you have really understood this question and if you have liked the way this solution was done, please do consider liking the video. So yeah, thanks for watching, and no rubbish talk, no nothing extra talks. I will see you in the next video. Take care.